Hi, today we're going to be discussing exercise number 3, which is about water balance and operations. So yeah, please, I'm happy that you're joining in. So um, as we were discussing before, this is something that you have been working on Pajaro Valley. And basically what you can see here is that there is an aquifer that supplies water for rural agriculture and the city of Watsonville, and also the city of Watsonville that puts also its water on the wastewater treatment plant that later will send it to this effluent. So as we know, we have this equation, the continuity equation. In this case, the change of storage is equal to the inflows minus the outflows. Please do remember that this one is this end of the month storage minus the previous storage will be equal to the inflows minus the outflows. In this case, if we do this subsystem here, what you will see is that in this case the inflows is the aquifer recharge. The outflows will be the um, uh, water going for the city of Watsonville plus rural plus agriculture. So if we substitute in this, what will be in this equation, what will be the balance of the aquifer? At any point it will be, in that case, St minus 1 will be equal to this inflows, which is the aquifer recharge at a given time t. So that will be the inflows minus the sum of the city plus rural plus ag. So how we're going to estimate the storage of the aquifer there? It will be the previous storage plus the aquifer recharge minus the sum of the water demands, which again is city, rural, and ag. Okay, so that's how you're going to be able to, if you substitute this in your exercise, that's how you're going to be able to solve for the aquifer storage. And if we take a look at this, so this is the subsystem number 1. Okay, so all of this, consider that this is 1. What we have actually the subsystem number 1 will be here. What we have in here. Okay, this will be subsystem number 1, which is this one that we're talking. Now for subsystem number 2, the inflows is, so again we can use the same equation. In terms of change of storage, we don't have any change of storage, so there is no water stored here. It's just water moving from one place to the other. In terms of inflows, what we have is that 66% of the water demand for the city of Watsonville, those will be the inflows, and also the amount of water coming from the river, and the outflows is pretty much this Q this outflow here, this Q out. So in this case, when we substitute in this one, so the change of storage equal the inflows minus the outflows. In this case, this is 0 because there is no water storing here. The inflows are this and the outflows are this. So in this case will be 0 will be equal to 0.66 of the city plus the river minus the outflow into the ocean. And if we want, because we want to substitute or to solve for this one, in this case, this Q out will be equal to 66 times the city of Watsonville plus the water coming from the river, this Q river. Okay? Hi, welcome to ESM 121, and this is exercise 3. So today we're going to be talking about mass balance and some system operation and water allocation policies. So please join me. So the first thing is that, well, the system, the water system that you're going to be working is the system that is in here, which is basically the Pajaro River. We have also the Pajaro Valley aquifer. And then this aquifer is supplying 3 water demands: rural, agriculture, the city of Watsonville. Once water is used in the city of Watsonville, that goes to a wastewater treatment plant and it's discharged. The effluent is going into the Pajaro River. Okay, so the first part is this section where you have to do these annual calculations. And for doing these annual calculations, basically you have to do you have to follow, well, you have to use this mass balance equation. So that's pretty simple. And you will have to do it for estimating the storage in the aquifer and also what will be the flow that it will go out of in Pajaro River. So for you to do this, I strongly recommend you that, and to estimate those and create the charts that are already here generated for you and so on. I strongly recommend you that you take a look at the video of the class at the minute 28 minutes 45 seconds, 28 minutes 30 seconds. That's where you're gonna find how I explain this mass balance. So I don't want to go into too much details on this video for that, but I strongly recommend you that you take a look at this, and then you will be able to respond these questions thoroughly. Now, something that I did want to make sure that you know how to do it is to how to call data from other tables to do it in your own table. So in this part, basically we're going to repeat this annual mass balance, but basically we're going to do it at the monthly time step. So in order for us to do that, basically what we have to do is to multiply the annual water demand. In this case, multiply, for instance, this value times the monthly distribution of that specific water demand, which if you take a look at it, it is in this table. So this table is telling you what are the monthly water demands for municipal, rural, and agricultural demand. So this is the monthly distribution. 7% typically will be used in January, 7% in February, then 9% by March, June, April, May, and June, and then July, August, September this much, and so on. Okay, so for you to do that, you have to multiply this annual water demand for a given user times his monthly distribution for that specific user. How to do that? Well, you're going to use a function in Excel that is called VLOOKUP, vertical lookup. So in order for you to bring here the annual water demand, so basically what you're going to do is you're gonna type this VLOOKUP, and then the number that you're gonna be looking is you're gonna be looking at this year. Now in this case, you want that the column doesn't move. That's what I'm hitting F4 until the dollar sign it got into the to the left of the B, which is the column. Then the table that we're going to be calling this 1999 annual water demand, it will be for the one that you have already finished, which it will be this, all the way to 2050. Now that I have selected this range, I'm going to hit F4, and basically what I'm doing is locking that table. So the table is not going to move. It will always go back to that specific table and look in that table the year. Then in terms of the column index, so Excel always start, so when you're locking this column, it is thinking that this is the first column. So we're actually, what we want is to bring back the value of the second column. So that's why we're going to do this value plus 1. So basically it's going to bring in the second column that we know that is, and when we want to bring the third, it will be this plus 1 and this plus 1. Finally, you want to bring the exact value. And in this case, for you to bring the exact value, so that it goes and look the exact value in the second column of the 1999 year, you have to hit false. Okay, so basically this is this annual water demand that you're seeing here. So this value is the value for this specific year. So for instance, for the next year, if we want to do it, it will be it is the same value because it's bringing always the 1999, and it will bring it for 12 months. When you go into 2000, then it's 7,676, which that is correct. Okay, so for now we have only brought the this annual water demand for that given user. Now let's actually look for the second. Well, what I'm going to do is I'm going to copy this equation and then place it somewhere here. Okay, so that's what I did. Then what I'm going to do now is try to bring the monthly distribution. So that distribution monthly for that one. So in this case, again, I'm going to use the VLOOKUP function. The value that I would like to look is the month. And in this case, again, I'm going to lock the column. I want to, that always is going to look into that column. The table or the array that I want to look this value, this first month, is this table. So that's what I'm going to hit F4. So that table is locked. The column that I want to look is the second column. So remember that Excel will, in this table, it would look this as the first column, second, third, and fourth. So we want to bring the data from the second column because we are estimating the monthly water demand for municipal use. And we will do the same this one, hit F4 plus 1. So I'm locking this specific cell. And then the last one, what I'm using is this false. Okay. So basically, I think something went wrong. Well, if you look at this, it's actually 0.07, which is the value that is here, which is 7%. So once we have done this, basically what I want to do is to copy this function that I have already created. I'm going to paste it in here and multiply those two. So basically this equation that you're seeing here is the same equation that is shown in your tutorial, in your exercise. Okay, so now once you have that, so this is about this much, which if you look at this, that sounds about right. This 489 that you're seeing here is this 489 that we are calculating here. And you can see that if we again hit it a little bit, so it will be 489, and then 638, 730, 633, 500, 662. So that seems that is working. You can now copy this one, and you can see that this is doing the same. So why? Now, as you can see here, this is when I did this is actually not working. Why? Because it's locking this. I lock this cell, so that's why it's always. It was looking before at this kind of column 1, and we don't, well, column 2 in. It's looking for column 2 in here, which is exactly this one, and also is looking for column 2 in this table. So that's why this is not working. So basically you can fix it by dragging this column here, and I think that should work out, and also in here. That will be one way of doing it. And now it seems that it's now calculating what is shown in the exercise. And again, if we drag this down, it should be working, yeah, as you can see here. So it is, are these results. Also, I think what I made a mistake here when fixing this one. Actually, what you have to fix is the row, not the entire cell. So if I just fix the row there, now it is working without that other one. So anyway, so those are two ways that you can fix it. Again, I think here now this one is working pretty well. You can calculate it now for the entire time series data. After this, you can estimate what is the total water demand for that specific month, which it will be the sum of this. And then you can estimate the aquifer storage, which is the previous storage plus the inflows minus the outflows. The previous storage plus the inflows minus the outflows. And that one should be, as you can see, working in here. So yep. So that will be for this section. I did wanted to make sure that you know how to do this. Also, I think for this one you can make it no border, and then at the end just a little bit of cosmetics, so it looks good. Yep, I think you will be good for doing this part.